Today's lesson is on dilations and scale factor. The first thing we're going to learn is scale factor. And what that does is identifies a ratio from one image to another. So whether you're going to make your image larger or smaller, it all depends on the scale factor. Always remember to put the first image you see first when writing. There are a few different ways to write scale factor. One is A to B, and it's separated by a colon, but you need to say the word to. So another way to write it is A to B. And the last one is a fraction, A to B. Throughout the lesson, you'll see me write it as the ratio with the colon and the fraction in between the most. So it says find the scale factor of the image from A to B, and I give you values here on the side. So the scale factor of this first picture would be 7 to 3. And then the scale factor of this image here would be 2 to 5. So you take your first image A to B. Scale factor helps us figure out how to make an object bigger or smaller. The correct term is called a dilation. We are still going to use coordinate notation, but we're going to change one thing. We talked about coordinate notation when we had an ordered pair. We would add or subtract when we had a translation, and that would move it left, right, up, or down. When we have a dilation, we need to make it bigger or smaller. Therefore, we're going to multiply our numbers by something to make it bigger or smaller. So let's try some examples. Here's your coordinate notation. XY goes to 3x, 5y. So if you have a ordered pair XY, you would substitute those in and to get your new ordered pair. So you would multiply this first 3 by 3, because that's when you substitute, to get 9, and this 3 by 5 to get 15. So here you have XY as well. When you substitute into that 3x, 5y, then you would get negative 12, 10. Over here, when you substitute xy, you would get 3, 45. And lastly, you would get 15, negative 35. The center of dilation is where all of your edges or points connect. In this case, if we were to choose 3 points on each of the images, one is smaller than the other, so it was dilated, and connect those dots, if you notice, all of those points meet at a common point. That is called the center of dilation. And in this case, it's at the origin. So it's at the center of the coordinate plane. If by chance I give you an image, so let's say we have this person and then that person grew, you have to pick that same point on the person. So if you choose a foot, you got to choose another foot. And then if you were to take that and connect it with a straight edge or ruler and connect those dots, mine's a little messy, I apologize. But what you'll notice is that all of those points have a common point, and that would be your center of dilation. Here we have a picture. If we use that it is at the origin, we can use different factors of the coordinates. So find the scale factor when ABC is reduced to DEF. So here we have A, B, and C, and here we have D, E, and F. If I tell you that the length of AB is 6 and it was reduced to 3, and I want to know what is the scale factor, we have to do our new point over our old point. Okay, so that's how we're going to find the scale factor. ABC is our original, which is our old point. DEF is our new, and that's what was created after we had our scale factor. So Our one side of A is our old, so that's going to be 6. And then our new is 3. If you are able to simplify, that's going to be your scale factor. So one hint, if your scale factor is greater than 1, it's going to get bigger or enlarge. If it is less than 1, so like 1/2, it is going to get smaller or reduce. So here we reduced ABC down to DEF with a scale factor of 1/2, which means that if we were to write our coordinate notation, it would say 1/2 x, 1/2 y. So here's an actual example with coordinates. So what I want you to do is take a second and find out what the ordered pairs of B, L, U, and E are. B is 2, 3. L is 3, 2. U is 2, 1. And E is 1, 2. I give you that your dilation is 2x, 2y. So what you do is you take each of those and substitute it in. So you have 4, 6. 6, 4. Taking each x and substituting it in, each y substituting it in, so you get 4, 2. 2, 4. So if you graph your new points, you're going to see that this shape, BLUE, should be 2 times as large as the original. So here you have 6, 4. Here you have 4, 2. And here you have 2, 4. If you label all your points, and you get your new shape that is twice as big. So when we are trying to find the coordinates under a new dilation, think of this. New to old. We don't need that. So what I'm telling you is that if I give you, like we did in the last problem, I said B is this point, under the dilation that I gave you, then the coordinate notation, it was now a different point. We made it bigger in the last example. But here I'm telling you that I'm giving you 4, 6. We put it through the dilation, and now it's 2, 3. So what are the coordinates of this new image under that same dilation? So how we do this is we figure out which one is the new, which one is the old. Your new is going to be what came out after the dilation. Your old is what you had before when you started. So you have to do this for x, and you have to do this for y. So here, your new, you take the x value, which is 2, and your old, which is 4, and simplify. Do it again for y. You have 3 over 6, which is 1/2. So you would say that your coordinate notation for this dilation is 1/2 x, because that's what we found here, comma 1/2 y, because that's what we found here. So if I say, here's your next point, what would it be under this dilation? You just substitute it in. 1/2 of 16 is 8. 1/2 of 8 is 4. Let's try another one. This dilation maps 3, 9 to 9, 27. This is your old. It was changed into 9, 27, which is your new point. So if we find what our coordinate notation is, we would say our new point to our old point for x, which gives you 3, our new point for y over our old, which gives you 3. So our coordinate notation would say that we are making this 3 times as big. That's our scale factor. Right here, that's your scale factor. That's how you know if it's going to get bigger or smaller. So if this is our new point, what would it be under this dilation? So you take negative 4, multiply it by 3, and you're going to get negative 12. And negative 5, multiply it by 3, and you get negative 15. The rules for composition is how you read it. So we are now going to combine translations and dilations. So if we write it how we're going to read it, it says the scale factor of 4. So just like translations, we're allowed to write just a D instead of the T. So it's translation or scale factor of 4, and then translation 3 units to the right. 3 units to the right would look like so. Because we're not moving up and down, we have to put that 0. Okay? You write this little of symbol. Now, what you do first, because it says the scale factor of 4 following a translation of 3 units to right, which means you have to take this translation and apply that first to that ordered pair xy. So if we were to do just the translation, forget about the dilation, think back to what we did on the first day, we would have said x plus 3y, or y plus 0. Knowing that we've now translated our image 3 units to the right, you now have to dilate it. So you do that second. And basically what you do is you take this number and you distribute it to everything inside the parentheses, even the 3. So you've translated and now you dilate it, means you're multiplying everything by that number. So you would end up with 4x plus 12, comma 4y. And that is your composition of the scale factor of 4 following a translation of 3 units to the right. So let's try number 2. It says the scale factor of 1/2 following a translation of 8 units down. So again, we do our translation first. So you have x, we're not moving it left or right, we're just going to move it 8 units down. Then we take this dilation and multiply it by 1/2. So everything in here gets multiplied by 1/2, even the negative 8. So you're left with 1/2 x, 1/2 y minus 4, because 4 is half of 8. That is your composition of the scale factor of 1/2 following a translation of 8 units down. Start your homework. Goodbye.